Morning instructional time is all before lunch, and you'll see that for TKN1, it's a pretty long stretch, as well as for 2-3. We are not showing the recess time in here because it isn't a hard recess time. It will adjust as teachers need it to adjust, but there always will be that longer break in the morning. For 4-6 and 7-8, you'll see that the time gets a little bit shorter, but that's because in the afternoon they also have a larger block of time for more academic type instruction. In the morning instructional time, you might find that we will be grouping kids based on projects, based on some idea they're working on, or perhaps we sometimes will cluster them according to something a little more traditional. For instance, there might be a humanities activity happening early in the morning that's combined with some social studies pieces. So then after the first part of the morning, we'll then switch and we'll have something that'll be more of a math science type of thing, maybe a STEM kind of portion. And that will happen for 2-3 days. And then perhaps another switch will happen and we need a longer period of time for a specific project that will need the whole morning. And then, of course, there's always opportunities for kids to be regrouped as they need to be for specific skills that they need to work on. And so that maybe even when you move down to the primary grades, that might be far more common as kids are learning how to read and how to start doing math and how to write. At Design 39 campus, it's really important that parents and students know that we will still be teaching reading, writing, mathematics, social studies, and science. All of the basic core curriculum is still a part of what we do. What we're adding are things like world languages, engineering, computer science, digital, visual, and performing arts. And this isn't being added as here's a class maybe kids could take. This is actually these are going to be threads from K through 8 that we're integrating into the school. You'll hear more about how this will happen later on. We really want to change the way that kids experience learning, and that's at the heart of what Design 39 is about. Often people try to figure out what we are by slapping labels on us like we're a STEM school, we're a gifted and talented school, whatever that is. Our whole goal is we want to change the way kids experience learning, and that's what we're about. One of the things we hear quite a lot is they hear that we're going paperless, and we're not going paperless. It's really about being paperless, or less paper, because we're still going to have students writing, cutting, gluing, drawing, doing all the things we need to do with paper. In addition, we have surfaces in the classroom that are going to be whiteboards, including tabletops, entire walls, so they will be writing there as well. So yes, they're writing, there is less paper, and that's the goal. We're moving into the digital age with education, and we want to make sure that we leverage the technology when it makes sense, and then use the low-tech stuff when it makes more sense. So an example of social studies. Social studies does not have to be taught out of a textbook with students answering questions. Instead, we can actually engage students into some thinking, into inquiry. So in this painting, which was painted in 1872, the picture that's being depicted here is about manifest destiny. But with students, you wouldn't start off by talking about that. Instead, you would look at a painting like this, and we start asking kids to just say, "What do you see here?" And they would start looking around and labeling the things that they can see and talk about this in groups. And then as they move through that, we can get to deeper questions by asking things like, well, why is there a figure in the center? Why is it so big? Who's small? Why do you think they might be small? And as you go through this, pretty soon kids start to get a really clear sense that this painting is trying to depict an idea. And that's really the goal of inquiry, is help kids discover what their understanding of the world based on their observations. So in an upper grade class, we could then add an actual piece of writing by John Sullivan on manifest destiny, and we can read that in conjunction with this piece of art to gain an even deeper understanding, and then to start using people's actual writings as part of the critical thinking process as well. This also works when you do something like ancient history. So here we see the head of a bearded man. This is at the Getty Villa in Malibu. And we're looking at this, and most kids look at this and think, ugh, it's a Greek statue. But what they don't know, and what they soon find out, is actually all of these statues were created for a specific reason, not just because they're pretty. So we will actually go through this with students and analyze different parts of the face and say, what do you feel when you see this? What does it make you think about? Who do you think this man is? And as you move through this piece, pretty soon they begin to understand there's a lot of information being communicated visually. And this is actually a work of propaganda. This particular statue, which did not represent this man in the slightest, this is what he wanted the world to believe he was. And so as we go through and we get to the idea of propaganda, they understand completely what that is before we label it. So a big part of what we want to have happen here is want kids to experience before they have to label these things so that the learning makes sense to them.
This is an example of an integrated curricular project in kindergarten, where students will be using literacy, math, social studies, and science throughout this project. It starts off by having students find a real problem out in the community. And they happen to find that cars were not stopping very well at the stop signs. So to be able to collect the data, students decided to hide a camera and film some cars during different times of the day, and then go back and observe them and see how many cars have stopped, slowed down, and kept going. So this was real graphing that students were doing. They were graphing real data, analyzing that graph. We actually had a police officer come in. The students had questions about the law, so we brought in an expert, and students learned a lot about the law. Then they started asking some questions that were more science, like physics, about cars needing to slow down to turn so they didn't fall over. Once we've observed all the data and graphed all the data, we found that only 5 cars actually stopped. 4 of them were turning left with a car coming, and 1, just students were walking across the road. So the kindergartners were just floored by this data and just motivated by this actual real data that they collected and analyzed. So they shared this data with local law enforcement, and then didn't stop there, talking about how to make a difference in our community. What can they do with this data to really help change some things? So maybe creating some public service announcements, creating posters, and really getting the word out to the community that this is their data that these kindergartners have found, and help to kind of make changes and differences in the world. This is a lot more motivating, engaging, and meaningful learning than maybe just taking a graphing page in the math workbook. These types of projects are happening in pockets throughout the district, throughout the country, and what we are going to do is have this to be the norm at Design 39 campus.
Here are some more examples on how we can integrate curriculum. Through digital literacy, we can allow students to use their technology to be able to read and write and connect ideas. In this first example, students use stop motion animation to create stories. Another example, in digital bookmaking, students take their own pictures and then write about maybe their family or a place they've been to. We can also use apps and programs to create comics to convey ideas. And through RSA animation, students video themselves drawing to connect ideas. And the power of student blogging. When students have choice in what they want to write about, they're more likely to create high quality writing, and they know that they have other people who are reading their writing and who are giving them feedback. And today we have the power to connect globally across the curriculum with people from around the world. In this first example, students are collaborating with other students from around the world to calculate the circumference of Earth. And in this next example, students are connecting with experts from around the world. This classroom is Skyping with a scientist who's in Antarctica studying penguins while she's living in her tent. So there's so much more power when we can connect real people and their expertise with our students.
So just a quick warning before I begin, I'm going to be talking quite a bit about computer science and engineering over the next couple minutes, and realize that our goal is not to produce a whole bunch of computer scientists and engineers. Our goal is to allow kids to pursue their passions, and if computer science and engineering is their passion, we want them to keep going in that area. Also, we know that the thinking and problem solving that goes into computer science and engineering is not only essential, it's necessary for these children as they move through their educational careers. So imagine that your child comes home and is excited to talk about math because of what they did in their programming class. Imagine that a child not only understands an algebraic concepts, but then they can go in and teach a computer to solve problems for them. I can be pretty sure that the child understands the math that goes into it if they can teach a computer how to solve that problem. Using computer science to work through basic problem solving, basic programming skills at the earlier ages, and allow them to explore even languages later. How we can integrate computer science into robotics through a PLTW program, using computer science for data analysis. And lastly, how cool would it be if kids created sculptures and art and then programmed a computer or created an application that allowed them to move the art in a showcase. And lastly, we want parents and teachers and students to know that computer science is inherently creative and team-based. We visited a lot of companies, and computer scientists and programmers never worked in isolation. They were always part of a team, brainstorming, problem solving together. We are going to be fortunate enough to offer the K-5 launch PLTW program at Design 39 campus, and as you can see, it is a STEM integration. For those of you guys that aren't too familiar, STEM stands for science, technology, engineering, and mathematics. So it's really cool to be offering this program because it will allow children to get that engineering thinking while they're learning about reading, writing, math. So we visited a school up in Menifee, California, and observed some of the teachers and their students, and what we saw was amazing. One of the examples we saw were kindergartners learning about structure and function. So kindergartners traditionally might read The Three Little Pigs. They might draw some pictures and color in those pictures and maybe make a song about the Three Little Pigs. But we say, why can't we go a step further? So what this teacher did is they actually gave groups of students, not individual students, but groups of students a bag of supplies, and they were asked to build a house that would withstand the force of a fan. And what was cool is that the teacher did it with them. Hers actually fell, and a lot of the student groups were successful. Those student groups that weren't successful, they just didn't stop then. They redesigned, they reprototyped, and they went through the design process to make sure that they encountered success. And we know that kids don't always get that the first time, and we want to make sure we get them to offer more opportunity for that. Another example we saw was kids working with energy and collisions. And yes, a teacher could have taken out a textbook and said, class, read pages 42 through 45 and write a summary about energy and collisions. But we feel that there's better use of a textbook, right? We can use textbooks to prop up ramps, and kids can make devices that go down the ramp where they can actually test whether their device was able to withstand a collision against a wall. So the key word here is explore. We want kids to have fun. We want them to smile. We want them to laugh. We want them to think like engineers and explore the world around them